Alright, so here's the disk. That's the radius. Before I start this problem, though, there's two things that need to be done. And first of all, that is to divide this 0.5 by 2 to get the radius, because they have given us the diameter, but we need the radius. So we just divide and get 0.25 meters for the radius. Also, I went ahead and converted this the 80 RPM revolutions per minute into radians per second, because angular speed is in radians per second. So I converted 80 into 8.38 radians per second. So now that I have done that, we know that this potter's wheel is rotating. Now, because it's rotating, I know that both the inertia and the kinetic energy are both rotational. They are both rotating. All right. But also, since the inertia is rotating, and this is a solid rotating disk, the inertia is going to be equal to that, a half mr squared. Okay. Also, the kinetic energy, because it's rotational, we can go ahead and use this equation. Okay, now, because the inertia is equal to this, we can just plug this in for the inertia right here. And the angular speed, because there's two, technically, it's going to be omega f squared minus omega I squared. But the initial omega initial is just 0, because the potter's wheel is starting from rest. So this can just be scratched out. It's just 0. So after I plug in all the numbers, this is the math for it. And part A, the work done, part A is 43.9 joules. So now in part B, they want the how many revolutions. How many revolutions does this wheel turn? So they have given us torque. We already figured out what the work done is. So we can use this equation to get what theta, the change in theta, is, because that's the only variable that we don't know. So we need theta by itself. That's how it's going to look. So we just calculated what the work is, and that's 43.9 divided by the torque, which was given, 8.2. And it comes out to, theta comes out to be 5.35 radians, but they want it in revolutions. So I needed to convert to revolutions, and that's 5.35 divided by 2 pi radians to get 0.851 revolutions for part B.